Welcome to part 3. So we've covered Real Science Radio's evidence against the Big Bang and the Big Bang predictions. That's our argument against the theory. Now we're going to look at big evidence from science for the Creator God. For as the New Testament says in the Epistle to the Hebrews, faith is the evidence of things not seen.
There is something mysterious, indeed very special, in the laws of nature themselves.
It looks in some respects as though our universe is rather special. It's quite easy to imagine a universe with slightly different properties, in which neither we nor anything as complicated as us could exist.
Of course, it is only because God exists that anything else exists. And it's only because of Him that there is truth and logic and reason. And in that context, the Bible defines faith. Faith is not belief in something you know isn't true. And it's not belief in something you can't prove. Faith is the proper response to the evidence of things not seen. I can't see electrons, but I respond to the evidence for their existence. And so I'll try to prevent kids from playing with electrical outlets. There is big evidence for the Creator everywhere you look. But to stay in the discipline that we've been in, physics, you didn't know that we tricked you into watching a physics lecture, did you? Now that we've exposed the error of the Big Bang, and to stay with physics, we now present the big evidence for the Creator, fine-tuning. It's the work of His hands. If you have ears to hear and eyes to see creation the way it really is, then you will see the world of God's handiwork.
Perhaps there is a rational explanation for why the laws of nature were set so precisely at the birth of our universe. For a while, mainstream cosmologists were content that once we understood better the underlying reason for the laws being set as they are, fine-tuning would no longer seem so mystical.
The general view of this, for most physicists, is that these fine-tunings are largely accidental, that the constants of nature are determined by some mathematical principles which have nothing whatever to do with our existence. Impersonal, mathematical, and we were just incredibly lucky that that mathematics happened to give rise to a universe with all this kind of fine-tuning, just precisely so.
We'll look at this evidence in 3 areas: the fine-tuning of the universe, the fine-tuning of the solar system, and the fine-tuning of the earth. But you guys are creationist exaggerators. Educated people don't think that there's any fine-tuning. Scientists don't see fine-tuning. I don't see any fine-tuning either. So let's hear from Stephen Hawking again, the world's most famous atheist physicist, whose bragging rights include holding the position of a creationist. That's right, the world's greatest scientist, Sir Isaac Newton, at Cambridge University, that's whose chair Stephen Hawking now holds. And Dr. Hawking has said, the remarkable fact is that the values of these numbers, that is, the physical constants of the universe, the value of these numbers seem to have been very finely adjusted. You can see that in this clip.
For example, if gravity were very strong, then anything as big as us would get crushed.
And the other laws are equally fine-tuned. Any slight adjustment to their value, and we would never exist. There is no known reason why these values should be set as they are. And the other laws are equally fine-tuned. Any slight adjustment to their value, and we would never exist. There is no known reason why these values should be set as they are, yet they do seem to be fine-tuned to allow our creation.
And then there's the world's most famous atheist evolutionist, Richard Dawkins. In the film Expelled, Ben Stein asked Dawkins, "If you meet God, what will you say to Him?" And in response, he quoted Bertrand Russell saying, "Sir, why did you go to such extreme measures to hide yourself?"
What if after you died, you ran into God? He said, what have you been doing, Richard? I mean, what have you been doing? I've been trying to be nice to you. I gave you a multi-million-dollar paycheck over and over again with your book, and look what you did.
Bertrand Russell had that point put to him, and he said something like, "Sir, why did you take such pains to hide yourself?"
Hide yourself? I remember reading back in the 1980s Dawkins' book, The Blind Watchmaker, when he admitted the exact opposite. This is what he wrote. Biology is the study of complex things that appear to have been designed for a purpose. So as I mentioned to Lawrence Krauss on Real Science Radio, you atheists admit fully half of the argument. Our world looks designed. But then you tell people, don't believe your lying eyes. It's obviously not designed. Sir Arthur Eddington was a famed astronomer, mathematician, physicist, and a pioneer in astrophysics. He wrote this: "The picture of the world, as drawn in existing physical theories, shows arrangement of the individual elements for which the odds are multillions to 1 against an origin by chance." And that word multillions, today we call that a googol. It's 1 with 100 zeros. And here's that Nobel Prize winner we met earlier, Arno Penzias. He wrote, "Astronomy leads us to a unique event, a universe which was created out of nothing, one with a very delicate balance needed to provide exactly the conditions required to permit life, and one which has an underlying, one might say, supernatural plan." British astrophysicist Paul Davies wrote this: "There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming." And then he adds, "There is now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life. Carbon and the properties of objects, such as stable, long-lived stars, depend rather sensitively on the values of certain physical parameters. It is fine-tuned for the essential building blocks and environments that life requires." Speaking of carbon, Davies mentions the carbon atom here. That's another of God's engineering wonders. Fred Hoyle authored the theory of stellar nucleosynthesis. Here's what he wrote: "Some super-calculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. A common sense interpretation of the facts suggests that a super intellect has monkeyed with the physics." It's been observed that monkeys somehow always find their way in there when you're talking about origins. But not only with physics, quote, "as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question."
The alternative explanation was also impossible to contemplate.
Physicists did not want to accept the idea that the laws of nature might be controlled by the benevolence of nature. Physicists did not want to accept the idea that the laws of nature might be controlled by the benevolence of nature. There should be no reason why the luck should just have it that we can exist. It's too much, it's a stretch. It's much too far to stretch.
So it's not all creationist exaggerators who point out that the universe appears to be fine-tuned. It's, well, almost everyone. And please see our website, realscienceradio.org/fine-tuning, for more and for links to these sources. Now let's go to Lawrence Krauss again, that atheist physicist. He's one of the new atheists. They're on a rampage against God. Here's how a new atheist deals with fine-tuning.
This is a brief history of time. This is a history showing the density of matter in the universe. As the universe expands, the density goes down. And this is the energy density of empty space, which remains constant. Now, we live right here, when the energy of empty space is 3 times the energy of matter. But if you stare at this long enough, and physicists have, you go crazy. Because there's something strange about this. We're living in the only time in the history of the universe when these two numbers are the same. At all earlier times, the energy of matter will exceed that in empty space, and at all later times, the energy in empty space will exceed that in matter. We're living at a very special time. But Copernicus told us we're not supposed to live in a very special time. We're living at a very special time. But Copernicus told us we're not supposed to live in a very special time. There's nothing special about 13.7 billion years. So why should this be the case? Well, physicists have come up with this answer. Galaxies exist. Why is that? Well, because let's look at this, and let's just say the energy of empty space were 50 times bigger. Then these two curves would not cross today, but here. Well, then these two curves would cross there. What time is that? That's the time when galaxies first formed. But if the energy of empty space exceeded that in matter before galaxies formed, then galaxies wouldn't form. Because the energy of empty space is gravitationally repulsive. So if galaxies didn't form, then we wouldn't be here. And this has led physicists to this crazy idea, which I call anthropic mania. If there are many different universes, and the energy of empty space can vary in each universe, it's a random variable, then only those in which it's not much greater than what we measure today will galaxies form, and only then will stars as planets form, and only then will astronomers form. So the universe is the way it is because there are astronomers here to measure it. So the universe is the way it is because there are astronomers here to measure it. This is depressing if it's true. Because it means this fundamental quantity in our universe, the energy of empty space, is an accident. There's no fundamental theory of why it has the value it has. There are many universes, maybe, and it's just an accident. We don't understand why gravity is the weakest force in nature, why the proton's 2,000 times heavier than the electron, why there are 3 generations of elementary particles, etc. We don't understand any of that. We've been trying to understand it since I've been a student. But particle physicists have leapt on this and said, maybe we don't have to understand anything. Maybe it's all an accident. It turns out there could be 10 to the 500 different universes, depending upon how you compactify the extra dimensions, and one of them, at least, is guaranteed to look like ours, because the laws of physics are different in every one. Is this science? I mean, if you could explain any universe, then you can't falsify the theory. And by the way, that's the second of the 2 things I wanted to remind you of. First, you're insignificant, and second, the future is miserable.
But you guys are creationist exaggerators. So what is it that everybody is all worked up about? We'll see for ourselves, beginning with the fine-tuning of the universe, and so particle physics and the fundamental forces of nature. First, the 1-to-1 electron-to-proton ratio throughout the universe yields our electrically neutral universe. Now, what is a proton and electron? Well, we know a bit about atoms, right? And in the nucleus of an atom, there's a neutron, and it has a neutral electrical charge. That's why we call it a neutron. It doesn't have a positive or negative charge. A proton has a positive charge, and an electron in a shell around the nucleus has a negative charge. So why is it important to have a 1-to-1 ratio? Well, because matter has the same number of protons and electrons, thankfully, we don't get electrocuted when we touch a piece of wood, or a rock, or when it rains. And how precise is this ratio? Well, this electron-to-proton ratio, what is the chance that a Big Bang would produce this virtually exact 1-to-1 correspondence of the number of protons to the number of electrons? It is less than 1 chance in 10 to the 37th power. That's been compared to hiding 1 dime, 1 small dime, in a pile of dimes that covers North America to 1,000,000 times higher than the moon is above the earth. That's a lot of dimes. And then picking out that 1 dime by chance on the very first try. So this extraordinarily consistent ratio of electrons to protons yields our very functional, electrically neutral universe.
Some of us, not all, to some of us, it looks like we have to live with the idea that the constants of nature, the laws of nature, everything that we know about, somehow was influenced by our own existence. That the constants of nature, the laws of nature, everything that we know about, somehow was influenced by our own existence. This is something which physicists hate the idea of.
Then we have the electron to proton mass ratio, which is perfect for forming molecules. In other words, not how many electrons to protons, but how little is the mass of the electron compared to the mass of the proton. If the ratio were larger or smaller, chemical bonding for the chemistry of life would fail.
We can imagine, as it were, turning the knobs, which were set up at the time of the Big Bang to determine how it expanded and what it was made of. And if we turn the knobs very slightly, we find that we would end up with a universe that would not be so propitious for the emergence of life.
Then there's the ratio of the electromagnetic force to gravity, which is 1 to 10 to the 40th. Now that's an average ratio. For electrons, it's even greater. For protons, it's a bit less. Now that ratio is so enormous, it's in the ballpark of the ratio of the size difference between an atom and the universe itself. And why is it important? Well, for example, the electromagnetic and gravitational forces are finely tuned for the stability of stars. And for the stability of pretty much everything else, for that matter. Pun intended. Let's take a look at this video.
The first force to emerge was gravity. The fate of the universe, its size, structure, and everything in it, was decided in that moment. Carlos Frank studies how gravity shaped the universe by creating artificial universes in this supercomputer. He gives each one a different amount of gravity. The first one he tried had too little, resulting in, well, nothing.
Gravity, it has shaped our universe. Or if gravity was weaker than it is, we would have a very boring universe in which everything would be flying apart so fast that there would be no galaxies forming.
Next, he programmed a universe with too much gravity.
If gravity was stronger than we think it is, again, we'll end up with a failed universe. Everything will end up in black holes. It has to be just so. It has to be just right.
Lucky for us, the Big Bang got it just right. The perfect amount of gravity.
Another example of fine-tuning is the gravitational and inertial mass equivalency. To get an idea of how unlikely and extraordinarily important this finely tuned equivalency is, here's a 2013 quote from New Scientist. "A large chunk of modern physics is precariously balanced on a whopping coincidence." And they're writing about gravitational and inertial mass equivalency, and they say these two masses are always numerically exactly the same. The consequences of this coincidence are profound.
Our universe seems to be defined by a set of numbers which in some sense look special. If we had different numbers, we would end up with a sterile universe. People react to this seeming coincidence in a number of ways. You could say it's the outcome of some kind of design or providence. We could say it's a brute fact we have to accept, because these numbers might be determined by some theory which we haven't yet discovered.
Then there's the electromagnetic force in the right ratio to the nuclear force. Now, the nuclear force is exerted between two or more neutrons and or protons, like exist in the nucleus of an atom. And the power of the electromagnetic force is fine-tuned to interact with that nuclear force. Then there's the value of the strong force. The strong force operates in the nucleus of an atom and it's 100 times more powerful than the electromagnetic force. If that ratio were changed, say by 1%, that would destroy all carbon, nitrogen, oxygen, and all of the heavier elements. There's a great DVD that we sell at Real Science Radio called The Privileged Planet. It's not from creation scientists, but it's from others who at least realize that the universe and life itself is so astounding and the requirements so precise that it all had to be designed. This brief clip from The Privileged Planet will help us understand the concept of fine-tuning.
To better appreciate this concept, imagine a machine able to control the strengths of each of the physical constants. If you changed, even slightly from its current setting, the strength of any one of these fundamental forces, such as gravity, the impact on complex life would be catastrophic.
If you increased it by a little bit, no large-scale life forms could exist.
Wow. At each of these levels, we're only looking at a small number of examples that scientists have offered as evidence of fine-tuning.
It seemed that hidden in the laws of nature was a value so precise that it was impossible to deny that our universe was designed. But a designed universe requires the existence of a designer, a notion that even the anthropic scientists did not want to entertain.
Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident.
The cosmological constant needs to be set to 1 part in a trillion, 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 trillion.
Cool. Now the fine-tuning of the solar system. Our solar system is positioned far from the Milky Way center in a galactic Goldilocks zone of low radiation. The beauty of the Real Science Radio website is how we build it year after year, continually updating the same pages, so that you don't have to read a dozen different articles to find out about Big Bang predictions, or dinosaur soft tissue, or the fine-tuning of the solar system. You go to one page, rsr.org/fine-tuning, and you'll find all of this material and often links as a springboard for more research right there for you. Our sun, placed in an arm of the Milky Way, puts it where we can discover a vast swath of the entire universe. If we were near the center, we wouldn't be able to see the heavens that God has created. Then we have the Earth's orbit. Earth's orbit is nearly circular. Its eccentricity is less than 2%. This means that there is very little difference between the Earth's perihelion and aphelion, our closest and farthest distances from the Sun. Significantly higher eccentricity, and forget this minor claimed global warming, Earth's ecosystems might completely collapse. The Earth's orbit has a low inclination, keeping our temperatures within a range permitting diverse ecosystems. The inclination of our orbit, think of the sun and the planets moving around the sun in a plane called the ecliptic. And we're almost perfectly aligned with that ecliptic. Now, the Earth's rotation on its axis works well with the low inclination of our orbit to maintain habitable zones. Our tilt, Earth's axial tilt, is within a range that helps to stabilize our planet's climate. It ensures the seasons, which are so wonderfully fun, and would have been even better before the global flood. And by the way, on that topic, as mentioned earlier, we have a video you might enjoy. Real Science Radio presents The Global Flood and the Hydroplate Theory, our best-selling science video. You can get that by going to our website, rsr.org. Consider next the moon's mass. That helps stabilize the Earth's tilt on its axis. And then its distance. The moon's distance from the Earth provides tides, and they keep life thriving in our oceans, and so all around the world. Then there's the moon's nearly circular orbit. That makes its influence reliable. Its eccentricity is about 5%. How is it that we end up with perfect solar eclipses? Well, it's because of the ratio between the moon's size and its distance from the Earth as compared to the sun. The moon is 1/400th the size of the sun, and it is 1/400th the distance that enables us to see perfect eclipses. An eclipse is a window into the science of astronomy. It is an eclipse during which we can see the sun's beautiful corona, the outer atmosphere, if you will, of the sun, that opened up for us the understanding of the heavens. Then there's the Earth's distance from the sun. It is fine-tuned to provide great quantities of liquid water, and all that liquid water sustains our climates and enables life to thrive on our planet. Our star, the sun, has an extraordinarily stable output of energy. If it didn't, the Earth could freeze or the Earth could fry. But God has given us an amazingly consistent energy source. The sun's mass and size are just right for the Earth's biosystem, and you'll hear atheists, for example, say that, well, the sun is just a typical star. But let them show you 2, 3, 4 other stars that are as consistent and perfect for sustaining life as our sun. Our sun is extraordinary. The sun's luminosity and temperature are just right to provide for Earth's extraordinary range of ecosystems. You know what's amazing about even the color of the light from our sun? The color of the sun's light is tuned for maximum benefit for our plant life, for its photosynthesis. Then there's the sun's low metallicity. That means it has relatively small percentages of the heavier elements. We're thankful for this because more heavy elements could destroy life on Earth. Now the fine-tuning of the Earth, which God created as part of His kingdom of heaven. Originally, the surface of the Earth, it was the rakia, the Hebrew word used in Genesis chapter 1 for terra firma, the firmament. That's a topic of controversy among creationists. If you're interested in that, please go to our website, rsr.org/firmament. I think you'll love it. So for the fine-tuning of the Earth, let's begin with our ozone layer. The Earth's ozone layer is just right. It filters out ultraviolet radiation, and it even helps with keeping our temperature stable. Gravity on the surface of the Earth, that's the Earth's surface gravity strength. It helps conserve the water in our atmosphere so that we don't lose it all to outer space. Then there's the Earth's rotation rate. The Earth's spin rate on its axis provides for a range of day and nighttime temperatures that allow life to thrive, not just to exist on Earth, but for life to thrive. And then the composition of our atmosphere. The Earth's atmosphere's composition, how much oxygen is in it, how much nitrogen, is just right for us. For example, too much oxygen in a forest fire could then ignite the atmosphere. So without God, yes, you'd have global warming. Because our atmosphere's pressure is just right for us, our lungs can function and water evaporates at just the right rate to support life. We can see through our atmosphere, right? Unlike Venus, which has an opaque atmosphere, the Earth's atmosphere's transparency allows an optimal range of life-giving solar radiation to reach the surface, but also, again, it enables us to study the heavens, and that's important because the heavens declare the glory of God. And there's life-giving rains around the world. Well, the atmosphere's capacity to hold water vapor provides both for stable temperature and for very helpful ranges of rainfall. We mentioned photosynthesis. Well, it turns out that plants have an amazing efficiency in their life-giving photosynthesis, and it depends on, of all things, quantum physics, which is shocking to biologists, that plants were designed in order to take advantage of quantum effects. Think of solar panels on the roof of a house. You want the solar panels to face the sun to maximize their efficiency as direct as you can. Well, a tree has leaves and the leaves are blowing in the wind, and so they're not always facing the sun. But God is the creator of the universe, and He invented plants on day 3. So what the Lord did was take advantage of a quantum effect. There's a wave, the light wave, And at some point, the wave function will collapse into a photon. So what the plant does is it conserves that wave coming in, and when it collapses, then it takes advantage of maximum energy. Now think about if Darwinists were correct and organisms simply evolved for their own benefit, then surely there could have been runaway consumption of all plant life. Well, God in His design prevented runaway consumption. That's another example of the fine-tuning of Earth's biosphere. Then there's the water molecule. The water molecule has astounding robustness. And again, that results from finely balanced quantum effects. Let's hear this from New Scientist. Quote, "Water's life-giving properties exist on a knife edge. It turns out that life as we know it relies on a fortuitous but incredibly delicate balance of quantum forces. We are used to the idea that the cosmos' physical constraints are fine-tuned for life. Now it seems water's quantum forces can be added to this just right list. Isn't God awesome? The Lord puts the evidence for His brilliance everywhere we look. Water is an unrivaled solvent. That is, it dissolves things really well. It has low viscosity. It flows well, which permits very tiny blood vessels. Water has high specific heat, so the oceans tend to maintain a stable temperature. It takes a lot of energy to heat up water, for example. Water has low thermal conductivity. For example, when it freezes solid, it helps to insulate lakes. That turns out to be very important. And as a liquid, it has high conductivity, and that lets organisms distribute their heat very efficiently. But water would be terrible for life to arise. Think about it. Water is the universal solvent. Those amino acids, proteins, and RNA strands that you need for life, you soak those things in water and you watch the solvent go to work. Water is great for life. As a solvent, it's terrible for trying to get life to arise from matter, which is impossible anyway. Yet there's NASA saying,
Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy.
Water is great for life. As a solvent, it's terrible for trying to get life to arise from matter. Just saying. As a lubricant, water is amazingly efficient and it is only mildly reactive. It has unusual behavior when it freezes. Typically, when material heats up, it expands. Water expands when it cools down, when it turns to ice. Turns out that that saves fish. So if water behaved like other molecules and when it got cold, turned to ice, it condensed and it sunk, then the fish in the lakes would be pushed closer and closer to the surface. Eventually they would die of exposure. So God made water for the fine-tuning of our lakes and for the creatures that live in them. Water has high vapor tension, and that helps to keep moisture in the atmosphere. There is a phenomenally harmonious water cycle. It actually stuns scientists who study it. And then finally, for water, it tastes great too. That's all from the world of physics.
The scientists were between a rock and a hard place. Their own discoveries were pointing them towards an intelligent designer.
This is its dislike of mixing religion into physics. I think they were somewhat afraid that if it was admitted that the reason the world is the way it is has to do with our own existence, that could be hijacked by the creationists, by the intelligent designers, and of course, what they would say is, yes, we always told you so. There is a benevolent somebody way up high in the universe who created the universe exactly so that we could live.
I have the honor of being the pastor at Denver Bible Church, which is nestled between Denver, Colorado, and the foothills of the Rocky Mountains. We love the astounding statements about creation in the scriptures. In closing, I'll share just one of them. Chronologically, the book of Job was the first book written in the Bible, and at Bob and Yurt Live, we have a fun verse-by-verse study of Job. That book was written in the time of the patriarchs. That's the time of Abraham's grandchildren, generations even before Moses. Job chapter 26, verse 7, says that God stretches out the north over empty space. He hangs the earth on nothing. What a beautiful statement of gravity, from the perspective not of ancient man, but from the perspective of our Creator God. For while the ancients were imagining the earth sitting on the back of a tortoise, God's word correctly described our world's position from the perspective of astronomy. God hung the earth on nothing. So we've looked at the evidence for the Creator in three areas: the fine-tuning of the universe, the fine-tuning of the solar system, and the fine-tuning of the earth. So you guys are not creationist exaggerators. You are Christians who love the Lord. Yes, that's who we are. And that's it, our evidence against the Big Bang. I learned a lot preparing this material, and I hope you have benefited too. And together, as long as we trust in Jesus Christ, in His death on the cross for us, and His resurrection, then we will be able to enjoy Him and the fellowship of the saints forever and ever. Until then, this is Bob and Yart for Real Science Radio. May God bless you.